Welcome to 11.2, Systems of Linear Equations. Now we're going to be working in matrices. We're going to write the augmented matrix of a system of linear equations, write the system of equations from the augmented matrix, perform row operations on a matrix, and solve a system of linear equations using matrices. I actually prefer working in matrices when we're solving, and it was really difficult for me to switch back to just solving it without a matrix for the last lecture. So I'm really happy to be working in a matrix again. So let's write the augmented matrix here. We're going to take all of the coefficients and put them into a matrix. So we have 7, -2, 7. Actually, before we do this, I'm getting ahead of myself. We want to move the constant terms to the other side of the equation. So what we will do is kind of isolate our variables. So we're going to have 7x minus 2y equals 7, and -7x minus 5y equals -2. That way our constants are separated from our variables. So now we can put it in our matrix form. We'll have 7, -2, 7. That was kind of messy. And then we have -7, -5, -2. And that's it. That's all we're looking for, is this augmented matrix. Next, we will perform the row operation that they're indicating. So for this one, they want us to do 6 of row 1 plus row 2. So 6 times row 1 plus row 2 is going to give us 1, 6, -3. Now, if we multiplied that by 6 and add it to row 2, we'll have 6 and -6, so 0. We'll have 36 and 4, which will be 40. And then we'll have -18 and +6, which will be -12. So that is our row operation. We multiplied by 6 and add it to the second row. Okay, next up, we're going to multiply row 1 by -3 and add it to row 2. So, row 1, we have 1, 1, -1, -2. And if we multiply that by -3, so -3, -3, +3, +6, and add it to row 2, we'll have 0, -3 plus 1, -2, and 3 plus 7 is 10, and 6 plus 3 is 9. And we didn't do anything to row 3, so that stays -8, 2, 5, 9. There we go. If you need to do it in 2 steps instead of 1, that's fine. If you want to multiply it and then add it in 2 steps, that works too. Okay, write the system of equations corresponding to the given matrix. Determine whether the system is consistent or inconsistent. If it's consistent, give the solution. Okay, so remember, let's see here. Recall, consistent has exactly one solution or infinite solutions. That's to be consistent. If it's no solution, then it's inconsistent. So let's take a look here. We have 1, 0, 0 equals -5, 0, 1, 0 equals -7, 0, 0, 1 equals 7. What does this tell me? This tells me that it's consistent with exactly one solution. X equals -5, Y equals -7, and Z equals 7. Okay, this one, 1, 0, 0, 1 equals -1, 0, 1, 0, 1 equals 9, 0, 0, 1, 7 equals -5. So this one, let's see here, is telling us if we have W, X, Y, Z, then we have W plus Z equals -1, X plus Z equals 9, and Y plus 7Z equals -5. So if we solve this out, we will get W equals -Z minus 1, X equals -Z plus 9, Y equals -7Z minus 5, and Z can be anything. So that is consistent because it has infinite solutions. Okay, now let's solve. So the first thing I'm going to do is turn this into a matrix. 2, -8, -4, 2, 2, 3. And then I am going to, actually I'm going to switch the rows. I'm going to put 2, 2, 3 on the top, and 2, -8, -4 on the bottom. That way when I divide it all by 2, then it's just 1s on the top. So let's multiply the top by a negative and add it to the second. So we have 2, 2, 3. And then if we multiplied it by a -1 and add it to the second row, we'll eliminate that 2. We'll have -10 and -7. Then I want to divide everything by, I'm going to divide the top by 2's, so 1, 1, and 3/2. And then I'm going to divide the bottom by a -10. That way it's a 1 as well. So -7 over -10 is 7/10. And then I'm going to multiply the second row by a negative and add it to the first row just to eliminate that last 1 there. So -7/10 plus 3/2 gives us 8/10. 0, 1, 7/10. So this gives us X is, what is that, 4/5. Y is 7/10. All right, first let's turn this into a matrix. 1, -1, 0 equals 5, 7, 0, -3 equals 49, 0, 7, 2 equals 14. So why don't we divide the second and third row by 7? That way we have ones. Leading one coefficients is really nice. 1, -1, 0, 5. And then we'll have 1, 0, -3/7, 7, 0, 1, 2/7, and 2. And then if I multiply the first row by a -1 and add it to the second row, we can eliminate that 1. So -1 and 1 is 0. +1 and 0 is 1. 0 and 3/7. -5 and 7 is 2. And we didn't do anything down here. Row 3 stays. Next we have, let's do a -1 times the third row. Now add it to the second row. 0. So let's actually use the middle row to eliminate the ones above and below it. So we'll do a -1 times the middle. Okay, hold on, slow down. The top row is already a -1 in the middle, so all we have to do is add it to the top row. -1 plus 1, 0. 0 minus 3/7 is -3/7. 5 and 2 is 7. So we eliminated that middle value. Now we can do the same on the bottom, but we have to multiply the middle by a -1 and add it to the third. So we're going to multiply the second row times a -1 and add it to the third row. So we'll have -1 plus 1 is 0. +3/7 and +2/7 is a +5/7. -2 plus 2 is 0. Now the bottom row, we can multiply by the reciprocal to turn it into a 1. So 1, 0, -3/7, 7. 0, 1, -3/7, 2. 0, 0, 1. So if I multiply by 7 and divide by 5, anything I do to that 0 is still going to be 0. Now I can use that 1 in the third row to eliminate the third column in all the other rows. So we'll have 1, 0, and I'll just multiply it by 3/7 and then add it to the middle and add it to the top. If I multiply the 0 times 3/7 and add it, then it doesn't add anything. So I really eliminated without changing anything else, which is always really nice. It rarely ever happens, but it happened this time, and that's really great. So our solution is x equals 7, y equals 2, z equals 0. Okay, our last example for today. Find the function y equals ax squared plus bx plus c whose graph contains the points 1, 0, -3, -8, and 3, 16. So if I plug in these values, we will get 1 squared a plus 1b plus c equals 0, which is just a plus b plus c equals 0. And then we'll get -3 squared a minus 3b plus c equals -8, which is 9a minus 3b plus c equals -8. And then we have 3 squared a plus 3b plus c equals 16, which is 9a plus 3b plus c equals 16. So as a matrix, we have 1, 1, 1, 0, 9, -3, 1, -8, 9, 3, 1, 16. Let's take a negative version of the second row and add it to the third row to eliminate those 9s, or the third row 9. So we'll have 1, 1, 1, 0. We'll have 9, -3, 1, -8. And then -9 plus 9 is 0. 3 plus 3 is 6. -1 plus 1 is 0. And -8, or +8 and +16 is +24. Okay. Next, I'm going to divide row 3 by 6. That way it's a 1. So we have 1, 1, 1, 0. And then we have 9, -3, 1, -8, 0, 1, 0, 4. Okay, now let's multiply row 1 times -9 and add it to row 2 to eliminate the last 9. So 1, 1, 1, 0. And then on the bottom, 0, 1, 0, 4. So -9 plus 9 is 0. -1 and -3 is -4. -1 and +1 is 0. And 0 and -8 is -8. Oh, you know what? I just forgot that I did 9s. So -9 plus 9 gives us 0. -9 and -3 is -12. Ooh, that was a close one. -9 and 1 is -8. And 0 and -8 is -8. My goodness, that could have been a big problem. Okay. Now, I'm going to switch row 2 and row 3. That way, since we solved, row 3 is completely solved. I'm going to put it in the middle where it belongs, where I like it to be. 0, 1, 0, 4, 0, -12, -8, -8. And now I'm going to multiply row 2 by a -1 and add it to row 1. So that way I eliminate that 1 in the second column. So I'm going to have 0, 1, 0, 4. So we've got -1 plus 1 is 0, and 0 plus 1 is 1. -4 plus 0 is -4. And then I'm also going to multiply it by 12, multiply row 2 by 12, and add it to row 3 to eliminate that 12 down there. So we have 12 minus 12 is 0, and 0 minus 8, and 12 times 4 is 48, and 48 minus 8 is 40. Okay. Next, I'm going to divide row 3 by 8. I'll divide it by a -8. 1, 0, 1. -4. 0, 1, 0, 4. 0, 0. -8 divided by -8 is 1. 40 divided by -8 is -5. And the last thing is going to be multiply row 3 by a -1 and add it to row 1 to eliminate the 1 in the third column. All right, 0, 1, 0, 4. So -1 plus 1 is 0. 5 minus 4 is 1. This tells us A is 1, B is 4, C is -5. So our equation is y equals x squared plus 4x minus 5.